Warning, the video you're about to watch contains mathematics at the level of precalculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosines River College in Sacramento, California. This is a continuation of a lecture on the law of cosines for a precalculus course. So this is not an introductory lecture to applications of laws of the law of cosines. It's just a review of applications of the law of cosines. So let's go ahead and just jump right into it. This problem, by the way, I use a problem like it, but I really don't know what a Seth Thomas schoolhouse clock is, so that was copied from somebody else's problem. But this problem actually occurs without the Seth Thomas schoolhouse clock. It occurs in calculus. And so my calculus students actually just finished doing a big, what's called related rates problem with this style of problem. So the hour hand on a clock is 4.6 inches long, and the minute hand is 6.1 inches long. Find the distance between the ends of the hands when the clock reads 4 o'clock. Well, let's go ahead and draw a picture. I read the problem. That's a first step in any type of word problem. Is just read it. Obviously, you need a win. That's the win right there. And the second thing you need to do is understand it, and that usually means drawing a picture. So we have something like this. And the minute hand is 6.1 inches long. This also, by the way, requires you to know what a clock looks like and what the minute hand is and what the hour hand is. The hour hand is the one that tells you what hour it is. So that's 4.6 inches long. And you want to find the distance between the tips of these hands of the clock at this time, 4 o'clock. This is the 4 o'clock time. So we want to find that distance, D. Well, how are you going to do that? They didn't really tell you anything else other than this, but there are a lot of implied pieces of information within this problem. The one piece of information that we really can take advantage of is the angle between the hour hand and minute hand. If you think about how many sections there are to a clock as far as turns, there are 12 sections, right? It could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. So there are 12 portions to the circle. And if you think about what we're looking at between time, let's call that 0 and time 4, that's 4/12 of a full circle. So we're looking at 4/12, this angle right here, which I'll call theta for right now. That angle theta is just 4/12 of a full circle. I'll write that off to the side. So 4/12, that's just 1/3. So theta equals, that's what is means, 1/3 of a full rotation, or of 2 pi. In other words, it's an angle of 2 pi over 3. Now, a lot of people, especially when you're working with law of sines, law of cosines, stuff like that, a lot of people don't like to work in radians. I kind of get it for law of cosine and for the law of cosines and the law of sines. So you can trade that out for 120 degrees if you want to. It's not that big of a deal. So I'll just write this as 120 degrees. If you're a little bit lost on why is it 4/12 of the circle, ask yourself this question. If it was 6 o'clock, what would this angle be? It should be 180 degrees, which is 1/2 of a full circle, which is 6/12 of a full circle. You've gone 6 out of 12 numbers out of the full circle. Here at 4, we've gone 4 out of the 12 numbers. That's why. All right, so let's go ahead and write down this information. You can kind of see it right here. It is going to be a law of cosine situation, but if you don't know, we'll go ahead and label things. I'll call this side or this angle C instead of theta. As I mentioned a moment ago, I was only going to keep that for a short time. Angle A, angle B, so therefore this is side B, this is side A, and this is side C. All All right. And I'll go ahead again and just write down my table of values here. Angle A, angle B, angle C, and side A, side B, side C. There we go. And we know what side A and B are, 4.6 inches and 6.1 inches respectively. And we also know what angle C is. It's 120 degrees. I do this because I don't personally like to memorize side, angle, side, 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 angle, whatever. I don't memorize any of that. Instead, I just fill out a table and say, do I have a full row done? If I don't, then I know it's law of cosines. There you go. Law of cosines. And we're only asked really to find that distance, C. So this is going to be a very nice problem. We happen to know that C squared is going to be A squared plus B squared minus 2AB cosine of the angle opposite side C, which is angle C. Subbing things in, we get C squared is equal to 4.6 squared plus 6.1 squared minus 2 times 4.6 times 6.1 times the cosine of 120 degrees. And you'll just take the square root of both sides to get what C is approximately equal to, which is 9.3. And by the way, that's 9.3 inches, right? Because all the units are in inches. So 9.3 inches is the answer. That's the distance between the tips of the hand on that clock at 4 o'clock. So there's a good example of using the law of cosines in an application. And by the way, you probably have noticed this is applications of non-right triangle trigonometry part 2. Part 1 focused on the law of sines, so this one is focusing on the law of cosines. The second and final example within this review of applications, we have a triangular field. It has a fence that is 212 feet on one side, 120 feet on another side, and 230 feet on the third side. Find the angle between the two longer sides. Okay, then. That's not what I was expecting it was going to ask. I thought it was going to ask, find the area of that triangular field, which I think is a fair question. So I'm going to answer that one as well. But we have some type of fencing. It's 212 feet on one side. It's 120 on another side. This is not to scale. And it's 230 on the final side. Again, totally not to scale. And we want to find the angle between the two longer sides. So I want to find this angle right here. Well, I'll call that angle A. This will be angle B, and this will be angle C. Why not? Therefore, that's side C. This is side A, and that's side B. Okay, well, let's build a table. Angle A, angle B, angle C. None of those were given. Side A, 120, side B, 230, and side little c, which is 212. And we want to find angle A. Okay, easy breezy. Let's go ahead and do it. Notice we don't have a complete row, so this is going to be a law of cosines. And we'll go ahead and do that with angle A there. So if we're trying to find angle A, we're going to use A squared is equal to B squared plus C squared minus 2AB cosine of the angle opposite little a, which is A. Of all of those letters, the only one we're missing is the angle A. So sub in, if I could spell in, that'd be awesome. So sub in, there we go. We get 120 squared is equal to 230 squared. Let's see, plus 212 squared minus twice 230 times 212 times the cosine of angle A, which we don't know. And then I'll just solve for the angle A. And that's just a manipulation problem. So it's 120 squared minus 230 squared minus 212 squared all over a negative 2 times 230 times 212. And you're going to take the cosine inverse of both sides. So I'll go ahead and do that, cosine inverse. And you will get what A is. And now you just grab a calculator for this. And as I mentioned in a previous video when we reviewed the law of cosines, you generally don't want to use the law of cosines too much because there's a lot of room for mistakes, especially when typing into a calculator. So if this were an exam or something like that for my students where I don't allow them a calculator, that's what they would answer for their angle A. But if you have, which you likely do, you have homework and you need to actually approximate this angle, be very, very careful with parentheses here. Make sure that that 120 squared minus 230 squared minus 212 squared is in the numerator. And I get roughly a 31.2 degrees for that angle A. So that would be the answer to this question. The question was, what is the angle between the two longer sides? 31.2 degrees, roughly. But there you go. Now, what if I instead were to say, what's the area of this field? If I was asking for the area of the field, you would use Heron's formula. And if you are in a class that doesn't use Heron's formula, you could just stop watching this. But Heron's formula, you would find the semi-perimeter, which is the sum of all the sides there divided by 2. So that would be the sum 1/2 times the quantity 212 plus 120 plus 230. And then the area of that triangle would be the square root of that S times S minus 212 times that S minus 120 times that S minus 230. And of course that would require a calculator, and but I'll quickly do it here. And in my computation, I get roughly 12,600, and I'm just going to say 18. I'm going to round to the nearest whole number. And I think these were in yards. Let me just double check. No, it's in feet. So square feet. Feet squared. There you go. So this is I just thought I'd give you more bang for your buck with this problem. So this is something that could be asked if you're taking a trig course or pre-calculus course. You could be asked to use Heron's formula likely. All right, so that does it for this video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much. That isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.